Cashier, that will be $69, sir. Engineer, what? Two significant figures? Hello again. Let's discuss how we can take the area of a parallelogram using the dot product. Let's get our colors. This is, oh no, looks like we're a bit too zoomed out. Just a bit more. Alright, let's say this is vector A, and this is vector B, and this is vector B, this is vector B. Now, how do we get the area of a parallelogram? This is a parallelogram. Just in case you're unfamiliar with the parallelogram, this is a parallelogram. Let's draw it differently. So, how do you get the area of a parallelogram? Well, that's easy. This is pre-algebra, I believe. Draw a height. Nah, just a straight line. No need to be broken. And the base. This is the base. So, oh, that's overused. Base. So, the area of a parallelogram is base times height. This is pre-algebra things right over here. So, why do we need to know how to take the area using the cross product? Actually, you don't really need to know, but this is a neat thing to know. This is a nice thing to know. So let's draw the component perpendicular, the component of vector A perpendicular to vector B. With this color, this one is a component of vector A that is perpendicular to B. Now, look at this. This is beautiful. Let's call this vector H for obvious reasons. Let's call this vector H. Look at this. Do they look similar? Yes, they do. They look similar. You're going to multiply its base, the base times the height. You're going to multiply the base times the height here, and here you would want to multiply the base and the vector that is perpendicular to B, which is essentially height. Alright, so we have here, so the cross product between A and B could also mean the area of the parallelogram, area of a parallelogram, but I guess you can say, hey, Vince, where the hell is the parallelogram? Well, to that I answer, this is the parallelogram imagined with this color. This is the parallelogram. Neat, isn't it? So I also want to give you one more thing, the area of a triangle. We all know this basic principle that a triangle is one half of the area of a parallelogram. So how it will look like is this. Let's get this color and draw. This is a triangle. Let's shade it in white. This is the triangle. Area of a triangle. Color green. Color this color. Area of a triangle is 1/2 the area of a parallelogram, which means, oh, forgot, this should be the magnitude. That is important. Alright, so that means the area of the triangle of a triangle is 1/2 the the magnitude of the cross product between two vectors. That is very, very neat. Let's box the answer. And maybe we should do a little practice. Alright, let's do some practice. And also, if you ever take the determinant, if you ever take the determinant of three vectors, that would mean you're taking the volume of the parallelepiped. So the determinant of three vectors a, let's not call it a, let's call it I, J, and K for laughs and giggles. Nope, that's too light. Alright. That would be equal to the volume of a parallelepiped. The vectors would look something like this. Let's see. They could look something like, oh no. Okay, we're back. Again, I was trying to draw three vectors that would form a parallelepiped. Then I accidentally pressed the button. Alright, so this could form a parallelepiped. Or no, this should form a parallelepiped. And it might look something like this to help you visualize. Alright, may look something like, oops, looks like my drawing is off, just as always. And this is not drawn to scale. And that is the parallelepiped with a neutral color. Parallelepiped. I'm not going to spell it out. Alright, let's do one example. So what is the area of x-axis, y-axis? Y-axis, this is the point 0, 0. Point 0, 0, right over here. And this point is 3, 3. And this point is 5, 1. Find the area of this parallelogram. Let's draw it in this beautiful color. So the parallelogram is this. Nope, that's not a vector. The parallelogram looks something like that. So the parallelogram is equal to the cross product between between this vector and this vector. So since we're from the origin points, the vectors are going to be 3 comma 3 times or dot 5 comma 1, which no, not dot, cross, again the confusion there, 3 3 5 1 equals 3 times 1, 3 minus 3 times 5 minus 15, the absolute value of that. So we get the magnitude, and that is 12 units. See you in the next one.